quickly look at the reactions of alkanes. First, one thing you should know is that alkanes don't have reactions for their preparation. Okay, we only have the hydration of an alkene to make an alkane. That's reverse, and we're gonna do it in alkenes. But basically, other than that, there's nothing else because alkanes, we actually mine them. Okay, we mine them, and we mine it as crude oil from the seabed, and then we take it through fractional distillation, which is boiling the crude oil, and then we take different stuff, okay? Because the different things in crude oil have different boiling points, and then we can get our alkanes, okay? Which is pretty much most of the stuff that you have from your crude oil. It's just alkanes. All those guys, those fuels are alkanes, okay? They have a lot of alkanes and a little bit of other things. So alkanes from crude oil, mined, then you go through fractional distillation. Now we want to see the reactions of them, the alkanes themselves. We only have two, okay? We only have two. One is going to be combustion. So in combustion, we are going to talk about the complete combustion and the incomplete. So we start with complete, okay? Complete combustion basically is going to be, you have alkane, okay? You have an alkane plus oxygen, okay? And it's going to give us carbon dioxide plus water. That's basically what happens in any complete combustion reaction, okay? Now, what you have to know about this is the ratios, okay? Sometimes you might need to, which is going to be, if you have Cn, remember N is the number of carbons, so what you got to know is the number of carbons you have in your alkane. So it'll be Cn H2n plus 2, that gives you your alkane, and then plus, for the number of oxygen, it'll be O2, it'll be 3n plus 1, O over 2 oxygens, to give us N plus, we start with NCO2, which is the carbon dioxide, and then plus N plus 1 H2O, okay? This is what we use. If I can remember it, you can. 3n plus 1 O over 2 for oxygens, then to give us NCO2 plus N plus 1 H2O. That's what we're going to need to know for this. Okay? It's an exothermic reaction. It releases, combustion is burning. And burning is the reaction with oxygen. When you are reacting with oxygen, you are burning up. That's combustion. Okay? Great. So this is what you get. Carbon dioxide and water. And you should know that it releases heat. So it is an exothermic. Okay? Here's an example. You have methane, CH4. This is going to be reacting with oxygen. Look at it. If I have this methane, I can know exactly what I'm going to get for complete combustion. There is one here, right? There is one more of carbon dioxide, of carbon, sorry. There is one carbon. So what? Not one more, but just one atom of carbon. So I'm going to have 2n, it'll be 2 times 1, which is 2 plus 2 gives you 4. So 4 hydrogens. Then in here, it'll be 3 plus 1, which gives me 3. 3 times 1 is 3 plus 1, 4. Over 2, you get 2 moles of oxygen. And here, what is it going to give me? I have, my N is equal to 1 in this case, okay? In here, I have NCO2, so it's just CO2. Then N plus 1 H2O, which is 2 H2O. This is going to be it. This is for methane, okay? This is my methane. And what you should know is that methane is a gas. Your alkanes will be gases. Oxygen is a gas. Carbon dioxide is a gas. But then the water is going to give you will be liquid water, okay? It will be liquid water. And if you are to ask, here is the, if we say delta H, this is the enthalpy change, okay? How much energy is gained or lost? And in here, it's negative 890 kilojoules to show that this is an exothermic reaction. Fine. Now, the next thing we go is part 2, which is the incomplete combustion, okay? Basically, in incomplete combustion, we can give you, or you can get 3 things. There are 3 possible things. It is when it undergoes combustion without enough oxygen, okay? If it's the oxygen is not enough, if it's insufficient for us to go through. So what we could have is, one, we could have carbon monoxide. That's carbon monoxide gas, okay? Or we could have carbon soot, which is the black stuff that you can see in exhaust. In exhaust, if you put your hand and rub inside the exhaust pipe of a car, you find your hand being black. That black stuff is called carbon soot. It's just this carbon. Or you could have, the last bad stuff is, you could have this smog. We call it smog. Smog is what you see covering the skies in countries like India, where it's not clear. They don't have clear skies like us, especially in big cities. And that is because of smog. You can check it out. This is going to be smog, and this is going to be soot, and this is going to be carbon monoxide. Okay? These are bad guys that you get from incomplete combustion. So let's put it. What am I going to have? I'll start with, let's use an example of methane. CH4, if it reacts with oxygen, we don't follow this now. We don't follow this, okay? We don't follow this for incomplete combustion. So basically, we have here our methane reacting with oxygen. Here, it is going to give us carbon monoxide, okay, plus water. Here's an example of carbon monoxide being given. Another example is if I have one more of methane, one more of oxygen, then I can get carbon soot plus water, 2 moles of water. If I have again one more of methane plus one more of oxygen, I can get this CH2O, my smog, and then plus water again. So here, these are the bad guys that you can get. Carbon monoxide, carbon soot, and smog. You can check them out if you want to see the picture. Now here we'll do one more reaction of alkanes and we will be done. So here it was just about combustion and you've seen it. Now we are going to go to the last reaction of alkanes and we're